You are welcome back to the Smart Way lectures on the Science Ambassadors series. Here we are going to still continue with the naming of alkanes. We have looked at several names. In our last video we did 2 examples, and so far we are doing almost about 5 examples. We are doing more examples to enable you understand and be familiar with the naming. So let's start by naming these compounds as we always do. Let's start by naming this compound. Now we will begin by applying the rules, which says that first count the longest continuous connected carbons. Okay, first count the longest continuous connected carbons. You normally count the longest continuous connected carbons that contain the functional group. This time the functional group is a single bond. That's why we are silent about it. Okay, so it is, you count the longest continuous carbon that contains the functional group. Because we are naming alkanes, the functional group is what? Just a single bond. So usually we are silent about that. So let's count the longest continuous carbon. Okay, so here we are going to get, if you start counting from this direction, we are going to get 1, 2, that is the straight direction, 3, 4, 5, and then 6. If you start counting from the straight direction, the parent name, okay, we have to write the longest continuous connected carbon, and here we have counted 6 carbon in the straight form, okay, in that straight manner. And then we explore other branches and see whether we can get anything out. Okay, we explore other branches. When we explore this branch 1, 2, 3, we have 3 carbons, which you know that 3 is too smaller than the 6 carbons, so you will not consider that. And then the next one, you are going to get 1, 2, 3, and 4. So if you count 1, 2, 3, 4, you get what? 4 carbon in terms of 1 connected to 2, connected to 3, connected to 4. It stops here. You can't count any other thing here. And then let's continue again. We are also going to get 1, 2, 3, 4, and 5. So here, according to this direction, we are also going to get 5. 1, 2, 3, 4, and 5. Okay, so 1, 2, 3, 4, and 5. And then let's explore the other directions. We are going to get 1, 2, 3, 4 connected to 5, 5 connected to what? 6. Okay, 6 connected to what? 7, 7 connected to 8. So according to this direction of count, 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 carbons if we are to count according to this 1, 2, 3, 4, 5, 6, 7, 8 direction. That is this direction and that direction. Have you gotten that? So when we explore all other avenues, we can see that the 8 will become the maximum. Okay, try all other avenues and you will see that 8 become maximum. Now when you get the 8, that means you are going to get a parent name called octane. Okay, we are going to get a parent name called what? Octane. Okay, so once you've done that, then that is fine. Once you get the parent name, the next is to what? Give the substituent name. So write the substituent name. The next one is to write the substituent what? Name. Okay, so write the substituent name. So by writing the substituent name, we always advise you that put the longest continuous chain in a max it out, so that it doesn't disturb your branches. Have you gotten that? So that it doesn't disturb your branches. It is very important to max it out so that it doesn't disturb your branches. Otherwise, you might consider the long carbon as the branch. So once 1, 2, 3, 4, 5, 6, 7, 8 become a stem or a parent, all that things become a branch. So let's identify the branches by circling them out. Okay, let's identify the branches by circling them out. So we have one branch here. We have another branch here. We have another branch here. We have another branch here. And we have another branch here. So these are the branches. These are the branches. The branches are the ones that I've marked out. So we have the first branch, second branch, third branch, and then we have this. So we have 1, 2, 3, 4, 5. Now these are the branches. Now these branches are attached to a certain number, okay, on the longest continuous carbon. So you have to identify the positions of the branch, okay, on the stem or on the parent, the position of the branch. So this one, when you start counting according to this direction, this carbon is placed on the second one. This substituent, which is called methyl substituent, is placed on the second carbon on the longest branch. Okay, on the longest continuous carbon, longest branch. Have you gotten that? So this carbon is placed on the second one. So let's write, we are going to write 2-methyl, and the name of the branch name is methyl. Okay, 3 carbon, 1 carbon substituent is called methyl. Okay, 1 carbon substituent is called methyl. And then the next one, we are going to get 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. So 1, 2, 3. I'm talking about the longest continuous carbon. 1, 2, 3, 4, 5, 6, 7, 8. This is the longest one. And this is the third carbon on the longest continuous carbon chain. And this carbon, okay, this CH3 is attached to the third carbon on the longest continuous carbon. Remember, the longest continuous carbon is the one in the red. And this carbon, this substituent is attached to the third one. So we also write 3 methyl. We also write 3 methyl. Okay, there. And there's also another substituent on the third one. That is, we have another substituent, that's Br. So, and the Br is also attached to the same third carbon. So we are going to get 3 bromo. We are going to get 3 bromo because Br is the same as bromo. Have you gotten that? Good, bromo. And then let's go from the third carbon. We are going to the fourth carbon, and we can see that there is something attached to it. That is what? So fourth carbon has a branch or a side attached to it, which is 1 carbon's compound. So we are going to get methyl. It's just 1 carbon, so it's called methyl. And then let's go the fifth one. So this is the fifth carbon. Do you see anything attached to it? You can see this is not part of the red. Okay, it's outside the red. So meaning that something is attached to the fifth one on the longest one, which is what so that we name it as this one methyl. So 5 methyl. These are all side that are attached to this position. So these numbers are the positions on the longest continuous carbon chain. So 1, 2. Okay, so we have 2 methyl, and we have 3 methyl and 3 bromo, and here we have 4 methyl, and we have 5 methyl. These are all side groups that I have identified. Now once you identify the side group, you have to explore the other count. You have to explore the other direction of count, else you get wrong. So how do you explore that? Now you initially began from this. You initially began from that. So we can also from this direction. So we are going to get 1. So 2. We are going to get 3. We are going to get 4. We are going to get 5. We are going to get 6. We are going to get 7. And we are going to get We are going to get 1, 2, 3, 4, 5, 6. Okay, so here is 7, and then I'm going to get 8. So when I count from back direction, from the backward direction, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8. From the back direction, I'm still going to get 8. So we can also write the names according to that order. So here I'm going to get 1, 2, 3, and 4. So this substituent is attached to the fourth one. So I write 4 methyl. Very, very important. 4 methyl. Okay, so I write 4 methyl, and then moving from the fourth one, that is from the back, I've gotten to the fifth, and I have a side group on the fifth carbon. So I write 5 methyl. Very important. I write 5 methyl. Okay, next on the second, the blue one, the sixth carbon, that is counting from the backward direction, from the blue one, I have 2 substituents placed on it. One is Br, one is CH3. So I'm going to get 6 Br, and the Br is called bromo. Have you gotten that? Bromo. And then we also have another sixth one. So the sixth carbon contains 2 substituents. One is bromo and one is methyl. Okay, one is bromo and the other one is called methyl. And then from the sixth carbon, I move to the seventh carbon, and I see that there is a branch attached to it, which is also 1 carbon branch, which is also methyl. So 7 carbon also have what? Metal. Have you gotten that? Very simple way of naming compound. Very, very simple. Now I've gotten the names. Now I have two set of names here. No, two set of names with two set of numbers. Now which ones am I going to pick? We just compare the numbers number by number or term by term. So let's develop the first set. This one we are going to get the numbers we are going to get. Let me write according to the colors that I've chosen. So here I have the first set. I have my 2, okay, I have my 3, I have my what? Another 3, okay, I have my 2, 3, 3, and I have my 4, and I have my what? My 5. Here I have my what? The smallest one is what? Is 4, okay. Next I have my 5. Next I have my what? My 6. I have my 6, and I have my what? My 7. So these are the, I think let me use the respective color so that it doesn't confuse anybody. So here I have my the fourth one according to the back direction. I have my 4, okay, that's the smallest. I'm writing according to the increasing order, okay. So 4, 5, 6, 6, and what? 7. So I have two set of what? Names. Which ones am I going to pick? I'm going to pick the one that, okay, is of the smallest order of numbers, okay. And so you can see from here, if I compare 2 to this 4, 2 is smaller than what? Is 4. So the 4 is what? Is out. So 4 here is out in the first one, and 3 here is also smaller than what? 5. So 5 here is out, okay. 3 is also smaller than 6. This is out. This is smaller than this is also out. So these numbers are out. If I compare it 10 by 10, this is far more what? Smaller as compared to what? As compared to this. So therefore I'm going to stick to this naming, okay. So I'm going to use this naming. Now once I identify the set, I'm now going to what? Give the name. How do I give the name? We said that you write the inorganic first alphabetically, okay. You write inorganic first alphabetically. If there are more inorganic substituents, you write inorganic first alphabetically, okay. So alphabetically, okay, and then you follow by writing what? Organic second, okay. Side group being organic, okay. All organic side group also comes alphabetically, okay. And then you write the what? The parent name, and then write the parent name. So that is all. So let's identify the organic and then the inorganic and name them. Which ones are the inorganic? Remember, we are preferring this method. So which ones are the inorganic? We have this as inorganic. That is, we have only one inorganic inside, which is the bromo. So that one is far easier because there's only one. We don't have any choice of what? Arranging according to the alphabet. So it's only one. So we have what? This. If there were many inorganic, you will choose the what? The A first before you choose the what? The one beginning the A first, followed by the B first, B second, and the C third, and the order. And then you will start again by naming inorganic according to A first, B first, and that order. So that one we don't range according to the numbers. We range according to alphabet. We arrange according to alphabet. So we are going to get 3 bromo, okay. We are going to get 3 bromo, and then what? Next one we are going to get the metals. Let's count all the metals. We have 1 metal, we have 2 metal, we have what? 3 metal, and we have 4 metal. So we have 4 metal. So 4 same metal repeating. So if we have 4 same metal repeating, and I told you that if we have, okay, 2 metal identical substituents, if they have 2, you name it as di. If you have 3 metal, you name it as tri. If you have 4 metal, you name it as what? Tetra, okay. If you have 5 metal, you name it as what? Penta. Have you gotten that? And if you have 6 metal, you name it as what? Hexa. So if the substituents are identical and it is 2, you name it like this. If it is 3, you name it like that. If it is what? 4, you begin by naming it this way. If it is 5, you begin by naming it penta. If it is 5, you begin by naming that. So that is how to name them. So but here I have 4 substituents. So therefore I'll name it as tetra. I'll name it as tetra what? I'll name it as tetra. But first I have to write the numbers there. Okay. So the numbers. I have my 2. The first one, I have my 2 meter. That is, I have my 2 meter. The second one, I have my 3 meter. Okay, 2, 3, 2, 3, and I have 4, 5. 2, 3, 4, and then what? 5. Okay, and I have tetra, that is all the metals are what? Are 4. So tetra metal. Okay, so tetra metal, then I'll add the last one to be what? 8. 8 is a parent name. The longest carbon is 8. So I'll name it as what? Octane. There's no separation. Look at how I am naming it. There's no separation between numbers is comma, between numbers and comma, between numbers is comma, please, between numbers it is comma, okay, and between numbers and letters it is dash. So please know how I am naming it. And between letters we don't do anything, okay, we just put them together. So this is how to name this compound, and this is the correct naming for the first compound. This is the correct naming for the first compound. So very simple. Count the longest continuous carbon chain in all possible directions. And then once you count the longest continuous chain, then max out the longest continuous chain so that you can identify the side group. Once you identify the side group, what it next, you then go and then write the name of the, and before then you write the name of the parent name, and then once you identify the side group, then write the side group. The side group are written in 2 sets. Once you identify the longest continuous chain, count it from the backward direction, and also write another form of what? A side group in 2 sets, and then you come and pick one according to the least possible numbers, okay, and you compare term by term, number by number, this by that, that by that, that by that, that by that, that by that. So you compare according to number, and you say that this one we will get what? Wrong. If you select this naming, you are going to get wrong, but if you select this naming, you are going to get what? Correct. Have you gotten that? So it is very important for you to know that, okay, it's very, very crucial and very important for you to know. So once you do that, and then you come and name all inorganic alphabetically, if there are many, then you come and name what? Inorganic alphabetically. If there are many inorganics, okay, there, that is chloro, bromo, bromo, and all those things, you name them alphabetically, and then you come and name organic also alphabetically, okay, like that, and your name will become very simple. So that is the first one, okay. We are going to name the second one too.
But the enemy won't worry me. I go show all of them tragedy. No be today, we start to. So if I sing my song, if I keep up for life.